Assalamu alaikum. Our today's lecture is about the difference between schottky and frenkel defects. Now, as I have told you that both of these defects they are stoichiometric defects, and we see that in both these defects, the ratio between the oppositely charged ions, cations and anions, that is that always remains the same. So this is stoichiometric defect. Now, as far as the difference between the two is concerned, now this Schottky defect, since it is this defect is produced due to missing of atoms or ions from their normal lattice, whereas this frenkel defect, in this case we see that some atom or an ion gets displaced from its normal lattice site, and it occupies some interstitial site. Now, number two is that in case of this Schottky defect, we see that the density gets lower due to the missing of, since both and the ions, cations and anions, they get lost from their normal sites. So the density of the crystal, in case of this Schottky defect, it gets lowered. Now, or it decreases, while as in this case we see that this frenkel defect, since it involves the dislocation, or it involves the shifting of the cation from its normal lattice site to some interstitial position, or interstitial site. So in this case the density does not change, that is the density remains unaffected. Then we have got another difference between the two is that this Schottky defect, it is generally shown by strongly ionic solids which have got high coordination number, this Schottky defect. And in this case we see the cations and anions, both cations and anions, they are of equal size. For example, we can see alkali metal halides, we got NaCl, we got cesium chloride, whereas in this case we see that this type of this frenkel defect, it is generally exhibited by those ionic solids which have got a low coordination number. And we see that in this case the size of the anion, it is larger as compared to the size of the cation. Then one more difference between the two is that in case of Schottky defect, since we see that in this Schottky defect there is an increase in entropy or disorderness of this of these ions, and this increases the, and due to the increase in entropy of the crystal, there is an increase in the electrical conductivity of the crystal. This is because when an adjacent ion in the crystal, it moves to occupy the hole, and this gives rise to another hole, and so on. So entropy increases due to the rapid transfer of ions and which occupy the newly created these holes. Now, as far as this frenkel defect is concerned, in case of frenkel defect, we see that there is also entropy also increases because the hole which is created by shifting of the cation to some interstitial position is filled by a neighboring ion, and which creates another hole, and so on. Now, one more difference between the two is that in case of this Schottky defect, we see that since it involves the missing of both cations and anions, or both cations and anions, they get lost from their normal lattice side. So the crystal in this Schottky defect, it becomes unstable because there is decrease in the lattice energy of the crystal as the attractive forces between the ions decrease. Now, the presence of too many holes may cause a partial collapse of the crystal. That means that if there are maximum number of these holes, it may lead to the collapsing of this crystal. Now, in this case, we see, in case of this frenkel defect, in this case also we see the stability of the crystal also it gets decreased. Then one more difference between the two is that dielectric properties. If we see the Schottky defect, we see the dielectric properties, they show a slow decrease in case of these schottky defects, while as in case of these frenkel defects, the dielectric properties of the crystal, they increase because similar charged ions, especially when the cation goes to some interstitial site, we see that similar charged ions, they come close, and this increases the repulsive forces, and we see that this leads to an increase in the dielectric properties of the crystal. Then one more difference between the two is that the electrical conductivity of the crystal, in both the cases we see that it increases due to the rapid formation of holes, and followed by the migration, subsequent these migration of the ions to these holes. Now in this case we see that in case of Frankel defect, again the electrical conductivity increases. So this is a comparison between the two defectors, this Schottky and Frankel defectors, since both are stoichiometric defectors. So this is for today. Thank you very much.